Hey, this is Rigas. This is Lab 7. I saw Latch. This here is my circuit, the one that is not covered by my finger. Uh, it's a NAND SR latch. What a NAND SR latch is, basically, generally SR latches are used. There are sequential circuits that are used to store a value. This is specifically it's a NAND latch. It could be like there are also NOR latches, but this is a NAND one. So this chip is for NAND gates. So how a NAND SR latch works is when both set and reset are 0. This is the forbidden state because both Q and Q bar are 1, which can happen. When set is 0 and R gets a value of 1, Q actually goes to 1 and Q bar goes to 0, which is the opposite of NOR SR latch. And respectively, when set is 1 and and reset is 0, Q bar is 1 and Q is 0. And when both of the inputs are on, like set and reset are both on 1, what happens is a value is stored. Like the Q gets the value that it previously had, and it stays on that for as long as it stays at 1 1. So here it is. This here, sorry for the light, but you can't do anything about it. This here is Q bar. Yeah, this is Q bar, and this is Q over here. So this, let me show you. This here, the one that's open now, is set. Then it's an input for to get the Q, and this here is reset R. And you see, as I explained, when R is 1 and S is 0, we get Q. Whereas when S is 1 and set is 1 and reset is 0, we get Q bar, as you can see. But now we want to check what happens if from 0 0, which is a forbidden state, and as you can see, both of Q and Q bar are open, which is wrong. We want to see what happens if from 0 0, the forbidden state, we go immediately to 1 1, which it doesn't go immediately, but we press both buttons together simultaneously, as good as I can, and we'll see through it can go through either 1 0, meaning that set will be 1 first and R won't get the value of R. Set will be 1 first, and so it will be 1 0, and then Q bar will be open and Q not open. That will be stored. Or 0 1, set will be closed and R will be open, and that will be stored in 1 1. So Q will be 1 and Q bar will be 0. We'll try that 5 times so we can see how many times it goes from 1 0 and how many times it goes through 0 1. Let's see. I'm trying to do the best that I can. So okay, 1 2 3. Okay, so that means that it went from since Q bar is open, that means it went from that S went 1 first. So the lag was in the reset. There was a big lag in the reset. Let's try again. First time Q bar 1. So set 1. Set got value 1 faster. 1 2 3. This time R1. R became 1 first because, as we can see, Q is open. So it's tied. let's go again. 1, 2, 3. This time set 1. So it's 2, 1 for the set. Let's try third time. 1, 2, 3. Okay. This time set 1 again. So it's 3, 1. Let's do the fifth time now. 1, 2, 3. Okay, this time reset 1 because Q is open. So 3, 2. So as we saw, 3 times it went from 0, 1 first to 1, 1, and 2 times it went from 1, 0 to 1, 1. That's why we saw 3 times Q bar being open, and only 2 times Q being open. So we found out that there's a bigger lag, like on average. There's a bigger lag in the reset button right here. So that is the lab. I hope you understood how my circuit works and what was the point. The problem with this lab is obvious. It's the human error of pressing the buttons simultaneously, because it's difficult to actually do it really good, almost perfect, and it can never be perfect, obviously. So we don't know if it's human error or if the lag is actually bigger on R or S. We can't know with the human error. But this is it. Thank you.